Hello geometry students, it's Mrs. Young. I am going to go over what you should have found from doing the 2.3.1 investigation. 2-101 was called the pink slip, and you could either investigate the questions using PASTA, which I recommend, or using the E tool, which becomes a little bit tricky to tell if it makes a triangle or not. So in part A, you had to build 4 different triangles. So I have that laid out here with PASTA. So we have the 3, 5, and 10. And so if we try to arrange that to create a triangle, what you should notice is that the 2 sides will not meet up. The 3 and the 5 are much too short, and we cannot connect them to create a triangle. The 2, 4, and 5 lengths, if we work on arranging those, will create a triangle. The 4, 9, and 12, my 12 looks like it's a little bit bent, but that's okay. Those also create a triangle. And then the 3, 5, and 8, we end up in this situation, and there's some thickness to the pasta, so you have to be aware of that, where the 3 and the 5 completely collapse and make a straight line and barely meet up with the 8. And so we end up with a collapsed triangle, a bottom length of 8, with the 2 sides kind of coming together and forming another flat line right on top of the length of 8 down here. So that actually does not form a triangle either. So we should have had 2 no triangles and 2 yes triangles. So then another question asks you to explore what the shortest possible side lengths and longest possible side lengths are for a triangle. So it gives you a side of 5 and 12 and wants you to investigate. This is one where the E tool might be valuable, but I'm just gonna draw some sketches here. So I'm gonna do one sketch where I assume that 12 is the longest side. So if we have a length of 5, in order to connect, this other side must be more than 7. If it is exactly 7, these 2 sides will connect together and collapse and make a straight line. So it has to be more than 7. If we assume that we have a 5 and a 12 as our shorter sides, and we want to know how big can we go, once this side length gets to 17, then it's going to collapse in a straight line. So this must be less than 17. Okay, so that means that our missing side, which I will call X, has to be less than 17, but more than 7. So we can write an inequality to express the range of side lengths that are possible. Okay, part D is asking you to explain what happened. So basically it's asking you to explain the triangle inequality. So what you're gonna do is take a pair of scissors and cut off the bottom of this page right here. And then you're gonna glue that into your interactive notebook. And we are gonna summarize what the triangle inequality is and then do a couple of example problems. Okay, so the triangle inequality states that any 2 sides must sum to be more than the third side. If it's equal to the third side, you're gonna end up with a collapsed triangle and it'll be a flat line. If the 2 sides sum to be less than the third side, then it's not even gonna meet up and create a triangle at all. Okay, so determine the minimum and maximum lengths for the missing side in the triangles below. So let's call this X. So if I have an inequality, we know that X is gonna have to be more than, well, let's flip back here and see if we can find a pattern. Okay, so the missing side length had to be more than 7 but less than 17. How do these numbers relate to 5 and 12? So the 7 is going to be the difference between the two numbers, and the 17 was the sum of the two numbers. So if I come over here, it's going to have to be more than 6, but less than the sum. Okay, so if x was 6, the 13 and the 6 would collapse on the 19 and make a flat line. But if x was 32, the 13 and the 19 would collapse and make a flat line. So we have to be somewhere in between those two values, and notice we do not have equal to's on there. So for the next one, if we call our missing side, I don't know, let's do y this time. So we have to do the difference of these two. 1 is less than y, and then we have to do the sum of those two, 29. And so the last one just allows us to do a little bit of practice and say, let's call that c. C has to be less than a plus b, but greater than, now here's something interesting, a minus b, because we said the difference. But what if b was the bigger number? Then we'd have a negative here. So we actually want to go ahead and put that in absolute value bars. We want the positive answer for that. And so this is a little formula is what we've developed here. Okay, now just to show you a couple of examples, a problem that you might see on homework or a test would be do the lengths 2, 8, and 9 make a triangle. So the triangle inequality says that any two sides must sum to be more than the third side. And the trick is to check the two smaller ones. So we want to know, is 2 plus 8 greater than 9? So that would be 10. Is 10 greater than 9? Is the alligator eating the bigger number? Yes, it is. So yes, it would make a triangle. So what if we look at another set of sides? So do the lengths 3, 3, and 3 make a triangle. Okay, so some students recognize right away that's actually an equilateral triangle. But again, take two of the numbers, they're all the same, add them together and see if it's greater than the third. So 6 is greater than 3, so yes, that works. Okay, so what about 7, 14, and 6? So you want to find the two smaller numbers, add them together, and check and see if it's greater than the third number. So 13 greater than 14? That is a false statement. The alligator is not eating the larger number. So this is no, not a triangle.